Hello, this is Mrs. Akers, and this is Algebra 2. We are on the week of April 20th, 2020. This will be the first video of the week, and I want to start with a review of linear equations. There are three forms of linear equations that we use in algebra. So, writing linear equations. We have three forms. We have slope-intercept form, which is y equals mx plus b, where m is the slope, also known as rate of change, of the line. B is the y-intercept. And hopefully you remember me talking over and over and over and over and over and over and over again. The x and the y here represents, the x and the y's represent all the points on the line. So since there is an infinite number of points, on a line, x and y remain in our equation unless they are equal to 0 everywhere. So let's look at an example. We have y equals 2x plus 3. This equation is in slope-intercept form. The slope is 2, the y-intercept is 3. So the slope equaling 2 tells me the rise is 2 while the run is 1. So it's up 2, right 1, or down 2, left 1, because two negatives make a positive. And since the y-intercept is 3, I know the point zero, 3 is on my line. As well as infinitely many other points that are on the line. Second form of a linear equation is called point-slope form. Point-slope form looks like y minus y1 equals m times the quantity x minus x1, where m is the slope, just like in slope-intercept form. I didn't write the m. Let's insert it in, where m is the slope Let me fix that, it's going to bother me. And x1, y1 is a known point on the line. There's nothing special about this point other than we know what it is. So in point slope form, we'll have a value for m, a value for x1, and a value for y1. Just like in slope intercept form, the xy's represent the infinite number of points on the line. So x1, y1 is a specific point. So let's look at an example of point slope form. I have y minus 3 equals 1/2 times x minus 2. I know my slope is 1/2. My x1 is 2. My y1 is 3. So my known point is 2, 3. Alright, third form, standard form of a linear equation. Have capital A x plus capital B y equals c. A, B, and C are real numbers. A and B together cannot equal 0. One or the other can equal 0, but not both. Standard form is good if you are trying to find the y and the x intercepts. So this is a good form to use to find the x-intercept, which we'll recall that occurs when y equals 0. And this is a good form to use to find the y-intercept. Might as well review that. That occurs when x is 0. Okay. So standard form is the only form where we don't use the slope to begin with. We can use standard form to find the slope, because you can find your x-intercept, you can find your y-intercept, and then you can count your slope between the two. Alright, let's look at an example of standard form. What are the intercepts of 3x plus 5y equals 15? Then graph the equation. It does not matter which intercept you start with. You can start with the x-intercept or the y-intercept. I'm going to start with the x-intercept. So to find the x-intercept, I'm going to let y equal 0 and solve for x. So I have 3x plus 5 times 0 equals 15. 5 times 0 is 0. 3x is equal to 15. Divide by 3. X is equal to 5. So that means the x-intercept of x equals 5 occurs at 5, 0. Now, to find the y-intercept, we're going to let x equal 0 and solve for y. So we have 3 times 0 plus 5 times y equals 15. 3 times 0 is 0. 5y equals 15. Divide both sides by 5. Y is equal to 3. So the y-intercept of y equals 3 occurs at the point 0, 3. So we have found both intercepts. In a linear equation, you will only have one x-intercept, you only have one y-intercept. When we get to quadratic equations, I hope you remember we could have up to 2 x-intercepts. In quadratics, we could have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. In linear equations, we will have 1 x-intercept. Alright, let's look at graphing this. We need to graph the points 5, 0 and 0, 3. So I'm going to draw a coordinate plane. One, 2, 3, 4, 5, 6, 7, 8 on my x-axis. 1, 2, 3, 4, 5 on my y-axis. My x-intercept again was 0, 5, so I stay on my x-axis and I move to the right 5. I place a point. My y-intercept is 0, 3, so I don't move left or right any. I go straight up to 3. This is a linear equation, so I should connect the points with a line. So this line represents all the points on 3x plus 5y equals 15. And we have completed that example. Alright, let's look at an example of graphing from slope-intercept form. So from slope-intercept form, let's graph y equals, let's see, let's go y equals 1/2 x plus 4. To graph this, start with the intercept. You always want to start with a point that you know. In slope-intercept point form, the point that you know is the intercept, specifically the y-intercept. So our y-intercept here is 4, so that occurs at the point 0, 4. So I'm going to draw a coordinate plane. One, 2, 3, 4, 5, 6, 7, 8. I'm going to go up 1, 2, 3, 4, 5, 6, 7. So I'm going to start by graphing the 0, 4, which occurs on the y-axis. Then, from B, you use the slope of 1/2 like it's a verb or an action. And it tells us direction. It tells us the action to move. It's the change in the y over the change in the x. So our change in y is 1, and our change in x is 2. So I'm going to change by a +1 in the y direction, while I'm changing by a +2 in the x direction. So from this point, I'm going to go up 1, and then I'm going to run 1, 2. And I'm going to plot a point. And then I can use M again to plot more points. And this should be review. So from 2, 5, I'm going to move up 1, and I'm going to run 1, 2. To 4, 6. And I'm going to connect the points with a line. So this line represents all the points on y equals 1/2 x plus 4. Now let's do an example of graphing from point slope. And the example from point slope is going to look a little different. I want to give you more of a real world example of point slope. Okay, in this example, I want to tell you that we know the point 15 and 450. And we also know that our M is -30. So first I want to put the information into my equation. So I have y minus 450 equals -30 times x minus 15. I don't want to simplify the equation. This equation's in point slope. I don't want to simplify it. I want to just graph from it. Well, I can graph the point 15, 450, but I'm going to break my y-axis. I'm going to go ahead and break my x-axis too. I know my slope's negative, so I know it's going to go down. So I know the highest I need is 450. And I know I'm going to be going down in units of 30. So I'm going to start up here at 450. And then I'm going to go down by units of 30. So I have 420. I have 390. I have 360. 330, 300. Now remember, this is broken. Also remember my x-axis is broken. Actually, let's not break it. Let's not break the x. I'm going to leave the x the way it should be. I'm just going to be very careful about my labeling. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm only going to go out to 20. Alright, so at 15, I'm at 450. So I need to be very, very careful. Then my slope of negative 30 means I'm going to drop 30. So from 450, I'm going to take away 30 and get 420. Then I'm going to run 1 and get 16. Then I'm going to drop 30 again and run 1. Drop 30 again, run 1. I'm going to graph this line. So point slope form allows me to graph from a point that's meaningful when the y-intercept might not be meaningful. Because actually what this is you put gas in a gas tank and you can drive 450 miles on 15 gallons of gas. And your car is getting 30 miles per gallon. So for each gallon more you use, you're dropping the amount of miles you can drive by 30. So I start with 15 gallons of gas. I don't really add 16 gallons of gas. I'm using a gallon of gas. So it'd be 15 minus 1 here. But that was the idea for this graph. Okay, please remember to answer the questions at the end of the video, and I hope you guys are doing well, and I will talk to you later.